Hello, my name is Paul Bevan from Siemens Digital Industry Software, and in this demonstration we're going to take a look at another example of how the new mixed modeling environment in the latest release of NX enables engineers to work efficiently with both precise and mesh geometry. The component you see on the screen is a topology optimized bell crank that's used in a horizontal stabilizer for an aircraft. We're going to take a look at how, using the new tools inside of NX, we can incorporate this into the overall assembly. You can see that when we take a look at the part navigator that we have a single convergent body, which is a mesh body and is the result of our topology optimization. Being a mesh body means it's made up of one single face, so I'm going to use a new powerful capability inside the polygon modeling environment that will enable me to construct topology that can be reused. So I'm going to start by entering the polygon modeling application and selecting the new Replace Mesh with Face command. This new command allows me to intelligently select areas of the mesh body that closely represent a plane and replace that mesh geometry with a planar face. And that planar face is precise. I can continue to select other areas of the mesh body that I want to replace. You notice you get a preview of the plane as well. Select a couple more. And I can also apply a constraint. So in this case, I'm going to make sure that these are parallel with a specific vector. So I'm ensuring that the output from this command is exactly what I require. So that's some planar topology created. Now I'm going to reuse the same command, but this time I'm going to specify I want to replace some mesh areas with cylinders. Again, intelligent selection makes it easy for me to highlight areas that I can replace. I'll select a final area here, and then I'll add another constraint to ensure that the cylindrical axis runs parallel to that vector. I'm going to continue to replace more areas of the mesh body. Again, more cylindrical faces. This time I select this area here, but I want to add a constraint this time that ensures that it's collinear with a previous face that I created. And again, I can easily do that. So how about verifying that we've created this geometry? Well, using visual reporting, part of the HD 3D tools in NX, I can use an out-of-the-box report which allows me to interrogate face types. Here you can see we have planar, cylindrical, and still our original convergent face. The color coding and visual tags makes it really easy to distinguish between them. So now that I've created this topology, what can I do with it? Well, I may want to start documenting the 3D model. And to do this, I'm going to add some PMI, product and manufacturing information. In this case, I'm going to add a radial dimension to one of the faces I created. And this is just not possible without the powerful capability of being able to replace mesh geometry with precise face geometry. So I'm going to add just one more dimension, this time between two of the planar faces. So I select my linear dimension and pick the two faces that I created earlier on in the demonstration, and again position my PMI dimension. I could continue to add more and more PMI to this model, but for demonstration purposes I'm just going to leave it with the two I've created. One thing I do want to highlight though is the fact that this PMI can be reused in downstream processes such as manufacturing. So I'm going to continue on with my design work and this time highlight another benefit of working in this mixed environment with mesh and precise geometry. One thing that I've not mentioned so far, but it's important, is what underpins a lot of what you've seen today, and that's convergent modeling technology. It's been around for several releases, and it's what these new applications and capabilities are built on. One further straightforward example of where convergent modeling technology can really help the design engineer is the ability to add modeling features. So here I'm going to add a chamfer to these two holes, and it's just easy to select the edges from the topology I've created and apply the chamfers. You can see in the part navigator that I now have a chamfer feature to go alongside my convergent body. In the final part of this demonstration, we're going to take a look at adding this component into the overall stabilizer assembly. So I change my display so I get to see the assembly, and then focus on the component that I want to attach the bell crank to. It's as easy as that. Now I'm going to find the parent assembly to this component, and we're ready to add the bell crank into it. So I'll enter the assemblies application, and I'm going to choose add component. We can do a search for the bell crank, and then we'll just add that into our assembly. We'll just select some geometry so that we can temporarily position it. And now I'll use the drag handles to move the bell crank into a more suitable orientation. We've rotated it, and now just simply drag it to a new position. All very dynamic and easily achieved. Finally, I'm going to use some assembly constraints to accurately position the bell crank. Here we're going to utilize the align constraint and select the axis of the cylinder I created earlier and align that with an axis of this component. And again, you immediately see it update. Finally, I want to center the bell crank, and again we have a constraint that allows us to do that. So I select two of the faces I created earlier and center those about two faces off this component. And again, you'll see my bell crank update. It's now in the correct position, and if I want to simulate the movement of the bell crank, I can simply use the move component command. I select the bell crank, and then I can dynamically drag it. You'll notice that it's maintaining the assembly constraints that I added earlier, allowing it to rotate about that axis. So let me just recap what you've seen. I started with a mesh body that was generated through topology optimization. I was able to very quickly create accurate topology using the new replace mesh with face command in this latest release of NX. I was then able to add PMI information directly to this topology so that I can start to accurately document my model. But more than that, the PMI can assist in downstream processes such as the manufacturing of the bell crank. You then saw the power of convergent modeling technology inside of NX when I added the chamfer feature directly to the mesh body. And finally, you saw me continue to use the topology I'd created to accurately position the bell crank in the horizontal stabilizer assembly using assembly constraints. I'm sure you'll agree that these powerful new capabilities in the latest release of NX enable a far more flexible and productive approach that designers can use when working with a combination of mesh and precise geometry. I'd like to thank you for your time and attention.